Hello class, this is Mr. Lehman. I want to talk to you today about our final topic in Unit 4, and that is Lewis dot or electron dot diagrams, two names for the same thing. So we got really in depth into talking about the electron in this unit, but moving forward when we get into bonding and chemical reactions, all we really care about are the electrons on the outside of the atom. And what do I mean by that? We're talking about the electrons in the outermost energy level. The electrons in the outermost energy level are called the valence electrons. Alright, so the valence electrons are the ones that can be shared, lost, or gained by atoms, and so therefore they're going to sort of determine the chemical reactivity of different atoms, different elements, and they'll help us figure out, the ratios in which things are going to react and how reactive they're going to be. So how do we simplify it? How do we just show the outside electrons? Well, for the main group elements, the S block and the P block, is really actually pretty easy. So let's take a look at how we do this. Alright, so what we're going to do is we're going to work through period 3. Alright, so period 3 is elements 11 through 18. So we're looking at sodium over to argon. So if you look at element 11, so sodium has 11 protons and 11 electrons. So we learned that the first two electrons will go in the first energy level, filling up the 1s. The next two electrons will go in the 2s. And the next 6 electrons will go in the 2p. That fills up the second energy level with 8. The third energy level, I'm going to use a different color here. The third energy level will have 1 in the 3s. So how many electrons does it have in the outermost energy level, in this red energy level? It just has 1. So why do all this if the atom isn't going to lose these electrons on the inside and they don't really affect its reactivity? Why show them? Why do we need to worry about them? Well, really, we don't. And so all we need to show is that there's 1 electron on the outside. And so the way we draw a Lewis dot symbol is we put the 2 letters or 1 letter that represents the element's name, and then we put how many electrons are around it in that outermost energy level around the symbol. So sodium just has 1, and if I'm going to cross out the name here so I don't redraw this every single time. If we look at our next element, magnesium, element 12 has 12 protons, 12 electrons. So magnesium adds a 12th electron to the 3s, making it 3s2. And so magnesium would have 2 dots around it because there's 2 valence electrons around it. So we like to pretend that this symbol is inside of a 4-sided box, and so I don't pair up my dots, my electrons, unless I have to. So I'm going to put 1 dot on the top, 1 dot on the left. Let me draw lines here so you don't confuse the dots and where they're going. If I go over to element 13, aluminum has 13 protons, 13 electrons, so aluminum adds 1 to the 3p, so 2 in the 3s plus 1 in the 3p. So aluminum would have 3 dots. And if I look at the one next to that, silicon has a 14th electron, so we add it to the outside, making it 3s2, 3p2. And so there's 4 electrons in the third energy level. So we do this group 1, group 2, group 13, group 14. And I'm probably going to run out of room, but you'll get the pattern. Group 15, so phosphorus comes next, and phosphorus element 15 has a 15th electron, so there's going to be 3s2, 3p3, and so because there are 5 valence electrons, we put 5 dots around it. And now I have to pair up, so my 5th dot will pair up with the 1st dot. Element 16, we're looking at sulfur, and sulfur adds a 16th electron, making it 3p4. And so I need 2 pairs of 2, 2 sides of 1, so 2 pairs of 2 and 2 sides of 1. And I ran out of room to the right, so let me make some room here at the bottom. There we go. And pretending we're continuing to the right, element 17, which is chlorine, adds a 7th electron to the outside. And so chlorine would get 7 dots around it. And then group 18 are noble gases. We'll fill up the 3p with 6, and so argon will have 8 dots around it. So here, these are the main group elements. You notice as we go left to right, they increase by 1 valence electron. Everything in sodium's family, like potassium, rubidium, cesium are also going to have one valence electron. That's pretty cool, right? So if you know one family member, then all the other family members are going to have the same number of valence electrons. And that's why they're very similar to each other. Group 1 is an extremely reactive group of metals. Why are they so reactive is because they all have one valence electron. They all lose that electron very easily, and in the process, lots of energy is transferred and released. And that's why we get sodium and potassium like catching on fire when we throw them in water and actually exploding. The energy is coming off, and they actually produce hydrogen gas. And hydrogen gas is explosive, and it actually can cause them to explode. So that is it for Lewis dot structure, or Lewis dot diagrams, and Lewis or electron dot diagrams, Lewis dot diagrams. So that's it for Unit 4. So if you need help, come on in. I'll be happy to help you after school.